Folks, it is my great pleasure to kick off this fall 2025 Society of Ethnobiology Distinguished Speaker Series talk with the great Andrew Gillreath-Brown. Andrew Gillreath-Brown is the Yale Lab and Technology Manager of Geospatial Sciences, where he oversees and advises geospatial research projects. He provides software and hardware support. He is also your main go-to person for offering training in remote sensing and geoinformatics. Dr. Gillreath-Brown holds a PhD in anthropology and archaeology from Washington State University and a Master of Science in Applied Geography from the University of North Texas. His research as an archaeologist and ethnobiologist has been published in places like PLOS One, Journal of Ethnobiology, Journal of Archaeological Sciences, and of course, Ethnobiology Letters, where he is a long-standing and extremely hardworking and important member of the editorial team there. He's the longest standing member of Ethnobiology Letters and is the holder of all the generational knowledge therein. Thank you, Andrew, for that. Through this work, he has over a decade of experience in geospatial analysis, machine learning, data science, working with satellite images, developing models for climate reconstruction, hydrological processes, and environmental change. This work has contributed to research at institutions including the Yale School of the Environment, Scripps Institution of Oceanography, Max Planck Institute for Geoanthropology, and the Santa Fe Institute. We here at the Society of Ethnobiology are the place to go for scholarship around what it means to be human and exist in relationship with all the other wondrous living beings that exist with us here on the planet Earth. We have a great set of programming for you this year, including a spring Distinguished Ethnobiology talk that will mirror this talk, including a conference May 20th to 23rd at the University of the South in Sewanee, Tennessee. And for anyone who's listening in who might be newer to the Society, we would love to see you and to have you get involved. We've got research awards as well, including grants for folks at all different stages of their careers. And I want to highlight especially the new Two Steves Award, a grant in aid of field research up to $5,000 to support any individual student, professional, or other conducting field research that advances knowledge in this field of ethnobiology. So if you're new to joining us, we'd love to see more of you. Without further ado, it's my great pleasure to introduce Dr. Andrew Gillreath-Brown and his talk From Drones to Satellites, How Remote Sensing Advances Ethnobiology and Our Understanding of Human Environmental Relationships. Take it away, Andrew.
Hi, everybody, and thanks again for having me. So today I'm going to talk about how both remote sensing and ethnobiology actually complement one another. And so we'll talk about in ways that can emphasize and help us understand human environmental relationships and think of new ways of taking ethnobiology with remote sensing. So I just want to acknowledge that Yale University is on indigenous peoples and nations' lands who have stewarded through generations the lands and waterways of what is now the state of Connecticut. So we honor and respect the enduring relationship that exists between these peoples and nations and this land. So why ethnobiology and remote sensing? Well, remote sensing can help provide some spatial and temporal environmental data that's hard to get otherwise. But this acts as a complement to ethnobiological data that we can't interpret what's actually going on in an image that's derived from people's knowledge and community knowledge about what we're actually seeing within say like a satellite image. It can help reveal landscape patterns, and together they can work together to help reveal these patterns across the landscape, as well as informing management and research. So just briefly, I'll talk about what is remote sensing, just in case you're like, I have no idea what this is. What does that even mean? So it just means that it's capturing and observing and measuring Earth's features or parts of Earth from a distance. So like from satellites, from a drone, from an aircraft. And so it's capturing some kind of energy off of the Earth's surface. And so here we're just seeing this change in urban sprawl from satellite imagery for Las Vegas from 1985 to 2011. So there are a couple of different ways that it's done, and that's through passive remote sensing and active remote sensing. So passive just means you're capturing energy that's reflected and emitted radiation. So from solar energy that's getting reflected off the down to the Earth and then up to the satellite. The other is active remote sensing, which just means that something like the satellite is sending its own signal, and then it's capturing that backscattered energy back off the Earth's surface. So the way that we think about all this energy that's coming back off of it is just through the electromagnetic spectrum, which you've probably thought about and seen that, the visible light spectrum before. And so this is just, it ranges all types of electromagnetic radiation. And so the light that comes out of a lamp or radio waves is all types of electromagnetic radiation. So most satellites use passive, so that one that was on the left in the previous slide, that measure reflected solar energy around 400 to 4,500 nanometers, which just gives us information about the color and characteristics of the surface. So they may measure emitted long wave radiation, which can give us things like temperature of the Earth's surface. So we can get other types of information off that as well, or trying to calculate things like soil moisture from those as well. So we typically use passive sensors, which are reflecting the solar energy, and then this is sort of just distributed across the electromagnetic spectrum, but is greatest within the visible bands that you see here. So objects reflect and absorb very different energy very differently across the electromagnetic spectrum. So for instance, clouds will reflect most of that energy back in the visible portion, but pass UV through. Water reflects a very small amount of blue light, but then absorbs almost everything else. Healthy vegetation reflects a little visible green, but not a lot of near infrared. And we'll talk about that a little bit more in just a second. And then irregular surfaces such as trees will sort of scatter the energy everywhere. So we can quantify the characteristics of an object using their spectral signatures. And I promise we'll move by all the sort of more technical talk after this. And then we can develop a variety of different indices like we can to figure out what healthy vegetation is. So for instance, there's an indices called the Normalized Difference Vegetation Index, or NDVI, that you might have heard of before, that measures the difference between near infrared, which strongly reflects which vegetation strongly reflects, and then red light, which vegetation absorbs. And NDVI is always between -1 to +1. So a vegetation index is what describes the greenness of the vegetation. So the relative density as well as the health of the vegetation. So here in this very simple example, you can see healthy vegetation versus dry grass. So if we look at near infrared and red with the healthy green grass, you have the really high near infrared and really low red there, versus when you get dry or dead vegetation, then those kind of come closer together, where you have lower near infrared but higher red. So that all to say is that you can get a sense of changes in vegetation across the year. So this is just a really short average example by month for the US of NDVI for 2023. So what is the value of ethnobiology and remote sensing? Well, ethnobiology and remote sensing can be very complementary to one another. So remote sensing is not meant to replace ethnobiology or work that's done within local communities. Because like I said before, there are things that you can see things from up above, but how do you interpret those things and what's actually going on the ground that you can't see from the satellite that you need to see on the ground from a very different scale. So ethnobiology really centers around people's lived experiences and place-based knowledge of ecosystems, while remote sensing provides spatial and temporal data on environmental change. And so they can work together to reveal how cultural and ecological systems interact with one another. So we can think about things such as food production systems to fire management, to animal migration, as well as forest regeneration. So there are lots of different areas that we can think about and how these two things could complement each other. As I mentioned, remote sensing does not replace traditional ecological knowledge or community knowledge about what's really happening on the ground, and how to interpret the complex interactions that you have going on between humans and their ecosystems. So, so for example, there are a variety of different indigenous programs that are looking to restore, that are revitalizing ecosystems, forests. But from the satellite imagery and remote sensing analysis, we could think about how we understand what's happened to that forest over time, and what areas might be what areas within that forest have degraded quicker over time. So those may be areas to like focus and focus on first, or what areas are regenerating faster from that community work that's been done on the forest. And so can we replicate what's going on in a particular area that's maybe regenerating faster than other parts of the forest. So I just wanted to briefly talk about a few different examples, areas that we could think about ethnobiology and remote sensing. And this is not meant to be comprehensive. You will probably have others that immediately pop into your head that are not on this list. So it's not meant to be exhaustive or anything, but just an idea of some of the different things that we could think about using remote sensing data and ethnobiology together. So in a very general sense, ethnobiology can provide the why and the how of what's going on. So the meaning behind a particular environmental pattern or interaction that we see from satellite imagery or drone. While remote sensing can provide the where and the when, although also archaeology, I'm an archaeologist, also does this part as well, especially when we're thinking about deep time. Where did certain things happen? When did they happen? And how did things change over time? Getting at that within archaeology as well. So, but trying to get out the part that the ability to track those relationships across space and time. So the first one that we could think about is food and agriculture. So ethnobiological knowledge about things like traditional farming systems or foraging systems can guide remote sensing analyses in terms of what's going on in the landscape, things about soil moisture, where do we want to focus on, and what areas have we seen the most change, or that's the most interesting aspects to a local community. So for example, we can look at things like different vegetation indices, as I mentioned, like NDVI or EVI is another one, in terms of trying to figure out when to best plant things as well as harvest things as well. But complementing that with people's knowledge of what's going on that already have an intimate relationship with their crops, but trying to help support that work. So, for example, a farmer in the Andes tracks the timing of the flowering of potato, as well as wild tuber growth, and how that can be used to better understand rainfall patterns. So, when is the rain happening? When is the temperature shifting that's affecting those flowering patterns? And so we can take things like remote sensing data like NDVI, as well as soil moisture, and complement these local indicators of changes within flowering and things like that to better understand and model those climate change impacts and what that might mean for food security, as well as agrobiodiversity on the landscape. But we can think about impacts on animals and connection with animals as well. So we can think about like a pastoralist knowledge of grazing patterns, what they see, or the pastoralists themselves working with those animals, taking them around to different areas. And this can be paired with satellite data to better understand where on the landscape things have changed and where they have degraded. So there are like big companies that actually do this, like Organic Valley, for example, where they would actually work on trying to come up with this information for the different farms that had grass-fed cows. And so, like you can see, if you have 10 different pastures that you're grazing your cows in, and one of them is like having a really bad during drought conditions, if one's like looking really bad, then you probably want to stay away from that one because if you overgraze it so much, you're going to end up impacting the growth of that of the pasture even into the next year, where you're going to have stunted growth the next year. So you want to give things time to recover within those instances. But just trying to help support what areas may still be good for a pastoralist versus ones that have become degraded or just really suffering from drought conditions. Another area is animal migration and habitat. So we can think about traditional ecological knowledge of animal behavior. So having information about routes and seasons and breeding sites. And we can look at satellite data to help understand and track those over time and better understand the full range of how those patterns are changing with their habitat and the areas that they're looking at. So we can use different instances, like for example, with the Inuit and Sami hunters, we can use their observations of both caribou and reindeer migration and how this shifts align to looking at different satellite data like snow cover, vegetation productivity, canopy height, tree height, and how that information kind of works together to better understand the impacts that it's having on these different species in terms of climate change and how that affects, altering a group's for hunting ability. Are they having to travel 20 miles away as opposed to 10 miles away, or what it might be? So where are they most likely to go, and where are things likely to shift? Another area is thinking about fire ecology and indigenous and burning. So indigenous fire management practices are often rooted in just the deep, detailed knowledge, accumulated knowledge of what's happened after fires and how to help best keep a forest or landscape healthy through fire. And so remote sensing can help kind of assess these patterns at a broader scale and understand what's going on across a much larger amount of space. So, for example, in Australian savannas, satellite data are used alongside Aboriginal fire knowledge to map fire patch burning and also evaluate biodiversity benefits. Or we can think about North American forests and looking at both drone or satellite imagery of post-burn vegetation and what the recovery of a forest looks like and how local knowledge and local observations about how important different plants are within that recovery. So, or how other culturally important plants rebound after post-fire events. So things like huckleberries or basket materials, and how these different species may respond differently to fire intensities. We can also think about the impact of animals as well. So thinking about these post-fire habitats and how it affects animals and their movement on the landscape, as well as the human animal interactions are altered by that change. So, whether it's a deer being displaced and moving to other areas, and then how quickly a particular species like huckleberries or something like that rebounds impacts how quickly a species might come back to that area, or how they are moving different seeds on the landscape to help the rebuilding of the forest after a fire, whether intentional or natural. A fourth area that we can think about is forest and medicinal plants, or just forest as a whole. So remote sensing can reveal changes in forest structure and canopy density or disturbance, just how open or closed a canopy is, and how that might affect different species being there, or different medicinal species being there. And communities can monitor the cultural significant species and where they are occurring within open gap spots or within closed areas. So forests really provide critical resources for communities, including medicinal plants and habitat for wildlife. So we can think about this openness and closedness of canopies and how that might affect different species. So there are some medicinal plants like False Solomon's seal or cat's claw that do well in those more open areas and tend to thrive more in that area. So if you have those spaces, then you have those useful plant habitats. And so we can get at some of that, and understand where that might occur on the landscape from the satellite imagery. But you really need, either local community knowledge or ethnobotanical surveys to really understand if in what instances those actually are occurring within open gaps. Because there may be, microclimatic factors or something like that, or different animal areas that animals in that are attracted to those areas or something too, that you're not going to get from the satellite up high, or even from a drone if it's a fairly dense canopy. And so we can local community knowledge holders they understand the forest structure and can inform knowledge about the pollinators and seed dispersers who are tied maybe to those same plants and who are taking those to different areas as well. So really understanding the complex interactions that can happen that you can't necessarily capture from the sky. So I wanted to briefly talk about this project by the Yale Ancient Pharmacology Program. It's a program run by Dr. Andrew Coe, and they really part of this is only a piece of their project. It's not the whole thing, but this one component really brings together ethnobiology, remote sensing, and community work on field work. And so they have, as part of the overall project, they have focused on the plant hellebore within Greece and doing a variety of different pedestrian surveys for hellebores across the landscape. And they know about the sort of medicinal and different properties of them through ancient authors like Pliny, who described hellebore as a very potent medicinal and purgative plant. Antikyra, I'll jump ahead here. So Antikyra is down here, and these are some of the different areas that they have focused on. Parnassus, you got Delphi, if you know about the Oracle and stuff, and many of the other places here. And so they from that, Antikyra in central Greece was renowned and known for being the home of hellebore, which was also linked to healing and ritual. Classical references, so these classical references in the text have really guided what areas they have gone to geographically, as well as targeting the hellebore itself. And so they have found a lot of these stands of hellebore or areas where it's thriving is around some of the ancient sites, modernly at least. And so they've done quite a bit of field work, and field teams have identified 16 different hellebore specimens from 11 sites all over Greece, different spots around Greece. And so they've recorded the local names, the uses, ecological settings, phenology on them. This is here a few people looking at a hellebore right there. And they have really worked with the community as well, so collaborating both with local residents as well as herbarium staff in sharing plant expertise. And they helped to, during these field, when they were making collections, they created voucher specimens, both for the Yale Herbarium, but also for their Greek partners, so that that information can be also kept and studied locally as well at the local herbarium in university. And so they've really had this community collaboration going on as part of that, and working with a local collaborator that shared some of their access and traditional knowledge as well. So where does remote sensing come into this? So they used UAVs, unmanned aerial vehicles or drones, with both multispectral and thermal sensors. Multispectral, I just mean it's capturing different wavelengths along that electromagnetic spectrum that we briefly talked about before. And so they went across, so you can see the drone. I'm not sure if you can actually see my cursor or not, but there's a little drone right there in the image. But they surveyed across slopes and sanctuaries and valleys, so kind of across different landscapes to see if they could find other places. And they used thermal imaging, which kind of revealed some of these microhabitats, smaller areas where hellebore was also thriving. So capturing the different spectral data can help differentiate where hellebore occurs versus other against other vegetation on the landscape. And so they're integrating both this UAV drone imaging, but also with the ethnobotanical data as well as the local knowledge in order to create these spatial models of ancient medicinal plant zones. So where are they occurring? Where could they possibly occur across the landscape? So this is just an example of a footage or a picture of the hellebore above. And so what they've done is taken this information to do some niche, what's called niche modeling. So just trying to find other similar places on the landscape with a variety of different environmental data and other information to understand where across Greece, where across the landscape, other places could hellebore also be growing as well. So that's kind of what the green of the background shows here. So the project is really trying to integrate a lot of this different information in interesting ways to better understand both the modern distribution of hellebore as well as where it may have occurred in the past. So if you do like landscape environmental reconstruction, which we like to do in archaeology, then you can try to find some similar locations that existed in the past that may have also had those. But there's also, of course, doing paleoethnobotanical analysis as well that they have done and uh, identified this as well as residues and things like that. Other types of archaeological data of being able to understand where across the landscape it occurred in the past that you obviously can't get from satellite data because it doesn't go back that far when we're talking about archaeological time periods. All right. I want to sort of like briefly shift, still talking about forest, but I wanted to talk about lidar just a little bit as well. Nothing too intense here, but so lidar, if you don't know, stands for light detection and ranging. Essentially, usually when you're gathering lidar data, you have a lidar sensor. It shoots lasers down. So like if you're shooting it from a plane or a drone, it goes down, and then that gets reflected back, and it's counting the time in between, and then you can essentially build a 3D model with it. So here, this is just a simple example of it's a property called the Richards property that Yale uses a lot. That's owned by a family, but they were able to use it for research. So this is just kind of a LiDAR scan of that landscape. But the one that I'll talk about the most here is the Yale Myers Forest. So it was a forest that Yale has had for a long time. That's sort of in the northeast of Connecticut. That was donated to the School of Forestry many decades ago, but it's been used for lots of different forestry and other environmental uh, research over the decades by lots of students, not just at Yale, but sort of all over the Northeast, because it has. You can just see from this orthomosaic, the simple stitched together photo, some of the different types of trees and vegetation that occur across the space. So you can do things like tree segmentation, so being able to try to pull out each tree within a space. So one and then from that we can map out. So this has been surveyed quite a bit, so it has a lot of the species already identified from field surveys and things like that. So there's a lot of different species that occurs here. And what we end up doing with like this model though is you can do a canopy height model, and so you can see the changes in the height of vegetation across the landscape and how some trees may be generally taller than others. And then also looking at the density, the openness again that we were talking about with certain different types of plants, medicinal plants, even thriving in those open conditions. And so you can do lots of different things with like trees and forests. You can even estimate carbon stock, so how much carbon is a forest holding, and understanding the things that are going on the landscape there, forest health, and things like that. And so you can take this data and do a variety of different things, and I could talk 2 hours on lidar or longer, but you can make other calculations like a digital elevation model. So understanding the elevation, you can calculate slope and aspect and canopy cover, vegetation height and complexity, and lots of other different things that you can use. And here you can use it like within a habitat sustainability index. So if we're thinking about other contexts, we can think about human-fox relationships, and why they may be coming in more contact with communities, and not this particular one because it's kind of by itself. But you could think about other species and thinking about other human animal dynamics and relationships, and understanding where and why animals might be moving to where they are on the landscape. Just another example of comparing lidar, the canopy height model there on the left with NDVI on the right. These are both still the Yale Myers Forest. And the last one is climate and ecosystem change. So just now coming back to that list of 5. But we can think about, climate change obviously affects sort of all aspects of an ecosystem, plants' growth patterns, species ranges, seasonal resource availability, and how climate change is impacting and making things shift to places they haven't shifted before. Even thinking about, tick-borne illnesses are popping up in places that they haven't ever had to deal with them before, which causes lots of other, complications in terms of healthcare systems not being set up to deal with those and things like that. But we can think about within these that traditional ecological knowledge provides a context. Again, it provides a meaning and context for interpreting what we might observe from remote sensing data. So things about understanding what's going on the surface in terms of animal migration, for instance, or how, oh, we used to find this plant in this area, but now we have to go all the way over here to get to it, and things like that, that you wouldn't necessarily understand how that has shifted for a community unless you have that local knowledge. So we can integrate these two together to help plan for environmental shifts and changing, as well as supporting adaptation strategies. So the satellites that I have mentioned here are just a variety of different, again, products that can be used. So Era 5 is used a lot for getting broad climate information kind of across the globe, but at a pretty large scale. And just there are, a variety of these different remote sensing data products that are out there. And what you want to use kind of changes depending on what question you want to ask and what scale you're also working at. So the last thing that I want to talk about is a project that I've been working on for the last few months, which is on flooding and early warning systems in Bihar, India. So you can see, Bihar occurs up here kind of in the northeast. So it's a very flood-prone area. It gets one of the highest, it's like the highest rate of flooding within India in terms of states. And you can see here on the right the increase of districts that have been covered with flooding, with an increase in flooding in the last several years as opposed to 2014 to 2019. So this just kind of shows one small area, a basin within Bihar that has rainfall here on the left, which are these solid lines, and then like a stream gauge here in the dotted. And really all you need to take from this is that there are periods where there's high rain and then you get flooding, followed by flooding. So the one that I'm going to focus on is right here around August 2nd. So you can see, so orange just means that the gauge went into a danger level. So there's a danger flooding level. None of these pop into extreme, but they're all go into the very, very high, particularly this one and this one. So this is the area that I'm pulling the gauge from. The gauge is, stream gauge is like right up here. This is around the Supal area within Bihar. This is just a satellite image of August 5th, so a few days after. So you don't always get daily imagery for an area. And then obviously if you're having a lot of rainfall and flooding, then the whole satellite image can also get covered by clouds, and then you're can't really get much information from it when the clouds, because remember the clouds are like sort of reflect everything back, so you can't get anything. There are other satellites like Sentinel-1 that you can like penetrate through clouds, but it has a little bit fewer day resolution than some other satellite products. So here is just a small snippet of something I've been working on is, trying to identify what areas across the landscape have been flooded. And so in the like sort of red points, those are households that are within the study area that they actually do surveys and everything in. And so this is a few days after the flood event. So August 5th, there was nothing for August 2nd. Even the small snippet of this that it covers was completely covered in clouds, so you couldn't really use it for this. And this is just another index like the NDVI that you can do. So it's just different wavelengths that you do some different equations with to pull out different types of information. And so the blue just shows that it had a higher water value, so flooded areas versus red, which is lower. And then all these gaps here are just essentially no data because that's where the clouds were. So if you look back over here, that's where the clouds were. Um, so nothing there. And and so we're really trying to get at is being able to understand, where is flooding actually happening on these locations, because you have the stream gauge up here, but you have households way down here. So does that, those levels that are triggered up here, does that actually what's happening down here? Well, we don't really know when that gauge is really far away. So trying to really understand what's going on at the household level. And so what they've been doing is we have people working in the communities to increase these early warning alerts. And so there's Android and WhatsApp. And so these get triggered by flood model as well as streams gauge data, and hopefully with this additional data that we're working on right now as well. So where does ethnobiology come into this? Well, this is sort of like where I want to future direction. I haven't started working on this quite yet, but there are a lot of different things that we can think about in terms of working with communities and organizers on how ethnobiological knowledge can be used both in flood prevention as well as for monitoring and adaptation. So we can think about things like animal behavior. So some animals like swamp deer or elephants will sometimes move to higher ground prior to flooding, or if we so we could track these populations when they do that to understand how they're changing elevation and where they're moving to. And if that's happening like a few hours before an area floods, then that's just more information to understand how dire it might be to get these alerts out at that time and how you're going to go about getting those alerts out. So we could integrate this with other local knowledge about how people are seeing these animals move around. Other things we can think about are plants and seasonal indicators. So many plants can give indications of likelihood. So it's not the plants aren't going to necessarily predict that there's a flood coming because they obviously don't happen in that real time like an animal moving to higher ground. But we can think about like, whether a crop or plants are getting too much water. And so that's going to give information about what's going on under the ground. If it's already saturated, then it's areas more likely to flood. And we can integrate this with like other types of data to understand, like soil conditions, and whether an area's if it's very clay, it has a lot of clay and it's very dry, then you're going to get more runoff flooding that way because it can't penetrate into the ground. But you have kind of a mixture within Bihar because you get a lot of silt. So a lot of areas can be very silty there because the gradient from Nepal, from the Himalayas into northern Bihar, is quite steep. So you get a lot of rushing water and silt transport there. But there are also areas that are clay rich as well. And so there are local communities within places like Nepal and other neighboring areas that have indigenous communities that have used a variety of different plants and natural and trees as flood barriers. So such as things such as mangroves. If you're within an area that grows mangrove trees, then they can really be a good barrier and with flooding. That's not the case in Bihar because it's landlocked, and so you don't really have mangrove places there. But there is the use of willow, salix, and bamboo. So bamboo can help prevent erosion as well as improving water retention and as well as other benefits. So here in these couple of pictures, this is a community within Nepal that had created these, used bamboo to sort of stabilize the riverbank, so to keep it from eroding away more. And then also these sort of like diversion things to help sort of redirect the water as well. And they had some neighboring communities that were like, oh, that's, very skeptical of it. But then it worked. It worked quite well. And so several other neighboring communities ended up like sort of adopting the similar thing. And so we can think about like these different types of local community mitigation factors that we could potentially do and take into account within these different contexts. We can think about tolerant crops like rice, which is grown a lot in Bihar. It's like the seventh highest state within India. That's going to be a little less susceptible to flooding. Rice needs a lot of water anyways, and so you can upkeep your food production during those times. We've also discovered that local dialects capture floods and farming and rituals in a lot of detail. And so these dialects contain lots of information about floods and flows across the landscape and what's going on. So it's important to, within these contexts of engaging local communities, as ethnobiologists are very good at doing, and collecting and preserving and sharing this information in order to help support communities in terms of mitigation and adaptation. And so it really has to be community led and community based. And so again, you can use the satellite products to support that, but again, it does not replace the work that ethnobiologists do in terms of community involvement. So just to sort of wrap things up, human ecological knowledge complements satellite and aerial data. We can think about it in terms of ground truth and validation, is what ethnobiological knowledge, it brings the context and meaning to remotely sensed data. Communities are often tracking culturally and ecologically important species, so which may not be obvious from satellite data alone. So identifying those important species, and ethnobiology helps prioritize what to monitor in large data sets. So you can have this global data set of satellite data, but like what do you focus on and what area and caveats. We can think about places like forest gardens and look at things like NDVI, and we can try to build models to find some of these other places like forest gardens that could help reconnect indigenous communities to those spaces, particularly when they've maybe had some that have been, wiped out by like large cities where there may have been forest gardens. Talking about Canada here. And so we can use satellites to detect environmental changes, but interpreting again their ecological significance often requires that local knowledge. Thank you.
A flurry of hearts and clapping hands coming up from you from the digital ether, Andrew. Thanks very much for that talk. We've got some time for questions from the group, as well as anything that might come up here in the chat. And of course, another reminder, if you like this, please come and see more of us at the spring talk and at the spring conference in May. Questions from the group?
or comments too.
Questions, posing as comments, always welcome.
Maria?
Hi, Andrew. Thank you so much. That was amazing. I was just curious, sort of like an ethical question, but I was just wondering if, and I've just heard this coming up a bit more about like remote sensing and remote data in other countries or in, indigenous territories, things like that. So are there any processes in place for, I mean, obviously, like with Google Earth, you can look at anything you want. I mean, and other data sets probably have more layers of having access to that. But I was just wondering if any of this work has come up, like questions about either gaining permission or at least informing people about how that's being used and yeah, just maybe some of the ethical things around um looking at these patterns in maybe sensitive territories that, obviously the people who live in those places have no control over satellites and that kind of imagery,
Right. Yeah.
but maybe
Yeah.
would like to.
Yeah.
So
But
I was just
I
wondering
mean,
if
they
that's come up
do, do to
in
some
any
extent against drones.
drones. Yes, yes, for
Because,
sure.
with a drone, you can get much finer resolution data and stuff like that. But again, that's it's sort of a very invasive thing. It's like right there. Yeah, I mean, I think, I've kind of I mean, there's definitely a lot of discussion around that, especially within uh, you know archaeological uses as well as ethnographic uses as well. But I think, I mean, I kind of think about it in terms of the way that I think about archaeology now that I didn't, when I first started in archaeology, I didn't necessarily think this way. But I think you have to engage with the community first, if you're going to look at like a reservation area or traditional land, then you have to engage with that community. And if they say, no, please don't look at don't look at satellite imagery or do anything in that area, then I think we just have to respect that and move away from that. And so I've sort of taken the same tact within thinking about archaeology and excavations the same way, particularly within traditional lands and places where indigenous people are still very much present, of respecting wishes when they're like, no, please do not dig. And like, yeah, don't dig. Um, so I think it's just, and I mean, of course, there's not really like a mechanism in terms of satellite imagery itself of like, um, I mean, they don't like gray out, indigenous lands or anything like that, though maybe they should. Um, but it's sort of a lot of the satellite products, especially high resolution ones, have moved to private, and so you generally have to pay a lot of money for those products, which is going to limit, a lot of people. Like even the highest resolution one that I have access to is 3 meters. And even that I mean, you couldn't really make out a person or anything within that. But again, I think if you're looking at indigenous lands, then I think you have to engage with that community to see, what their questions would be, or types of things that they might be interested in. And if they're not, then leave it alone. So.
Thank you.
Trinity in the chat says, thanks for the great presentation. Any ideal certifications or licenses for further getting into remote sensing? Asked from a current college student.
It kind of depends on what you want to do. I mean, definitely I mean, just in terms of getting into remote sensing, I mean, taking some basic like remote sensing courses and how you analyze that data, because it's there lots of different types of software and stuff out there that you can use. Some of them are, quite expensive, but they're also, the good thing is that there's actually become like quite a flurry of open source software to process remotely sensed data as well. And but if you're wanting to get into like flying UAVs, then getting your pilot's license, Part 107 license, would be a pretty important component for that. So. And there are, and if you look around enough, or you can even email me that there are quite a few people that do like sort of short workshops on different remote sensing aspects as well. So.
A great question, and the Society of Ethnobiology will be hosting some workshops for graduate students and current students as well, thinking about professionalization and some of these toolkits too. So stay tuned.
I will also say that there's a really nice sort of more point and click at some of these different products called Climate Engine, that makes it a lot easier than having to, do the coding and stuff. So it's a really nice application just to like sort of explore some of the different products.
Yeah, I was just going to thank you from my class.
Want me to move this so they can see the class? Are you fine with that?
And I do have a little question about one of the beginning slides that showed the caribou equals reindeer anyway,
Yeah.
and lichen. And I wasn't sure what the remote sensing could pick up from lichen, since there's so many kinds of lichen and not all are palatable and none are really nutritious.
Right.
Yeah.
Yeah. It's sort of when you sort of get into the more like finer resolution things, it definitely gets more challenging, especially from satellite imagery. Some of those things you can start to kind of get at more with drone imagery, but it is difficult from satellite imagery to sometimes get sort of at those things. But there's a lot of work on like understanding, like, I mean, people are looking at like beech leaf disease with drones and trying to be able to find where those are, and everything too. So, but yeah.
Anyway, thanks for your talk, and we'll sign off now.
Okay. Thank you.
Bye.
Bye.
Seeing no hands and no further questions, I want to say thanks again to Dr. Andrew Gillreath-Brown, who is the Lab and Technology Manager at the Yale Center for Geospatial Solutions. We'll have another talk in this series later in the spring, but until then, I hope that everyone stays well. And if you enjoyed this, we'd love to see more of you here at the Society for Ethnobiology.
Thanks, everybody.
Thanks so much.